Hello, dear students, and the rest of the learners. Welcome to part 48 of a 95-part series of tutorials in object-oriented programming in C++. In this tutorial, we are going to look at inheritance and class scope under inheritance. My name is MemJM, or you can simply call me Emily Swap. A class data members or a class data members that is variables declared in the class definition and member functions that is functions declared in the class definition belong to that class's scope. Non-member functions are defined at what we call file scope. So already, my dear students and the rest of the learners, you can see that when we have members within a class definition, those members have various scopes. If the members have been defined or declared within a class, that those members have the scope for that class, meaning that a member who belongs to a certain class can be able to access other members within that class. If you have a method and a data member within the same class, that method can be able to make use of the data members within that class, meaning that that method has a scope, and that scope is that class. But if a member or if a definition or a declaration has been made outside of a class, it simply means that various classes can be able to access that member. And we call those members that have been declared undefined outside of a class to be non-member functions of that class. And if they are not members of a class, then we say that they are non-member functions and their scope is the file. So several classes can be able to access them. Within a class's scope, class members are immediately accessible by all that class's member functions or methods and can be referenced through one of the handles of an object. That is an object name, a reference to an object, or a pointer to an object. The type of the object, reference, or a pointer specifies the interface, that is the member functions accessible to the client. Variables declared in a member function have a block scope and are known only that function. In other words, those variables can be said to be private. They are private because they belong to only that function or that method, and it's only that method that can make use of them. So even if you have a class and you have a data member or you have a member who has been defined outside of a method, within the class, we can say that that member has that class as its scope. But if within a class, we have a method or a function, and there is a definition or a declaration of a variable within that function, it simply means that member who has been defined within a function, which is a member of a class, has what we call block scope. Why? Because it's only known by that function, or it's only known within the boundaries of that function and not the boundaries of the class. If a member function defines a variable with the same name as a variable in the class scope, the class scope variable is hidden by the block scope variable in the block scope. In other words, we are saying if you have defined a method within a class, and within that class, we have a member who has been defined outside of the function or outside of the method, but within the class. And that member has a name that is similar to a member who has been defined within a class or within a method. I repeat, if you have a definition of a variable within a class, but that member has been defined outside of the method within that class, it simply means that that member as that class as the scope. But if you have defined a variable or a member within a function or within a method in a given class, that member is only known within that method. And therefore, that member who has been declared or defined, or that variable which has been declared or defined within a method or a function has what we call the block scope. And this block scope is the function itself. In such a case, if you have a member who has been defined within a class but outside a method with a similar name to a member who has been defined within a function or within a method in that same class, then the member who has been defined within the function overrides the one who has been defined outside of that function. So the member who has the class scope is hidden by the block scope variable in the block scope. Such a hidden variable can be accessed by preceding the variable name with the class name followed by the scope dissolution operator. The dot operator or the dot member selection operator is preceded by an object's name or with a reference to an object to access the object's members. The arrow member selection operator is preceded by a pointer to an object to access the object's members. When you declare a derived class, therefore, an access specifier can precede each base class in the base list of the derived class. And my dear students and the rest of the learners, if this is your first presentation that you are going through and you're not able to understand what I'm referring to as the base class, the derived class, is scope dissolution, access specifiers, I kindly request that you go through the series of tutorials and the object-oriented programming in C++ that have been posted in Emerisoft ICT YouTube channel so that you can have a clear understanding of this presentation. Therefore, my dear students and the rest of the learners, when you say that you declare a derived class, or when you declare a derived class, an access specifier can precede each base class in the base list of the derived class. This does not mean, or this does not alter the access attributes of the individual members of a base class as seen by the base class, but it allows the derived class to restrict the access control of the members of the base class. You can write classes. You can write classes using any of the following three access specifiers or scopes. Number one, in a public base class, the ones always have the one public and protected is used to refer to members of the base class that remain public and protected members of the derived class. In a protected base class, the reserved one public and protected are used. Public and protected members of the base class are protected members of the derived class. Number three, in a private base class, public and protected members of the base class become private members of the derived class. In all cases, therefore, the private members of the base class remain private. Private members of the base class cannot be used by the derived class unless friend declarations within the base class explicitly grant access to them. My dear students and the rest of the learners, do you remember what are called friend classes or friend methods? If you don't remember, kindly go through the previous presentations in MLSWAP ICT YouTube channel under the object-oriented programming in C++ with your focus being on the videos that have the word friend. And with that, we have come to the end of part 48 of this series. You can now continue and listen to part 49 of 95, in which I'm going to be speaking about inheritance and overloading. Congratulations, therefore, for learning part 48 of 95 on inheritance and class scope. You can access videos for the other parts in object-oriented programming series, as well as other computer or ICT videos by clicking or tapping on MLSWAP ICT YouTube channel below this video. Remember to subscribe to the channel by tapping on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly feel free to write to us through the email mlswap@gmail.com. Thank you very much for listening to me, and God bless.